Welcome to this video of explaining maps and textures without code. Today we'll be discussing normal maps. Talk about the use and application of these maps, what they do, and what all the colors and values mean. After that, I'll quickly go over some methods of making them yourself. Normal maps are used for laying relief and texture on an otherwise flat surface. You could do this in the model's geometry as well by adding polygons, but they can quickly become quite heavy for your PC as the poly count starts stacking up. Using normal maps is a cheaper method to bring this kind of detail to your objects. A normal map achieves this effect by changing the way the object reflects light. The normal map dictates in which direction the light is reflected, creating an illusion of texture. This way it looks like there are edges or slight height differences in the geometry where there actually are none. The object's geometry remains unchanged, so looking at it from the side will show that the object is still flat. Now a normal map looks like this. Most maps are used to convey specific values. Those are stored in the colors you see. In a normal map there are 3 values to be stored, so it uses 3 color channels, red, green and blue. Combining all these channels will result in a color value, which depicts which exact direction you want the surface to face, or the light to reflect. An easy way to look at this map is to imagine the red and green channel as if they are 2 snapshots of the surface being lit from 2 different directions. Red is used to depict the angle of the surface going from left to right. It looks like there's a light coming from the right side of the surface. Green is used for the angle from down to up. It looks like there's a light coming from the top. So if we take this piece of a normal map. The base color for a normal map is half red, half green and full blue. This is usually the most prevalent color you see in normal maps. This color means the surface is facing in its standard direction, the way it would face without a normal map. Now if you lower the red color, the direction of the surfaces is angled towards the left. Making it a higher value angles it to the right. Same goes for green, but instead it angles between bottom and the top. Changing both values at the same time changes the angle diagonally, giving you full freedom in what direction you can face the surface. Now here are some examples. These 2 simple lines make it look like there's an edge going over the plane sticking outwards. And this map makes for a cylindrical shape. I've recreated it with geometry to show that it perfectly mimics the reflection of light. But looking at it from an angle, you can easily destroy that illusion, so keep that in mind. So we've explained what the red and green channel mean. The angle of the surface from left to right and from bottom to top. So what does the blue channel do? Well, the blue color is used to depict the steepness of the slopes and edges you create. The lower the value is, the steeper the edge is. What this basically does is it intensifies the normal map. This is a slightly harder concept to integrate in your work process. But luckily that shouldn't be a large problem. You generally paint the blue channel in its standard value of 255 and get a good looking normal map. While it adds more detail to the normal map, giving a more accurate depiction of depth, keeping it at a standard value isn't breaking anything, it should still look fine. As you can see in this normal map, exchanging the original blue channel for a channel filled with an equal value of blue gives a minimal difference in detail. Just to demonstrate the effect of darkening the blue channel, I've added a darker circle to it. You can see how it sort of intensifies the normal map when it's darker. You can also notice that it gets pretty extreme when the blue begins to approach black, so beware of that when integrating this in your own maps. Normal maps can be made in several different ways. You can use 3D software such as ZBrush to project a high poly sculpt onto a lower poly version of it and directly export the normal map using that software. You can also use software like XNormal or the NVIDIA plugin for Photoshop to generate a normal map from a height or displacement map. These softwares usually also give the option to generate it from a picture or another texture. It should be noted that using this method leaves out information about the object the normal is used on. This can, for example, lead to odd seams. You could paint it yourself, although that often requires a lot of work. There are special painting softwares that might be worth a try, such as Krita or Sprite Illuminator. A common method of creating normal maps is generating a normal map from a 3D sculpt or texture and then fix it up using painting software to get rid of unwanted details or errors. If you're not sure how to handle the blue values during painting, it's best to just leave it at the standard 255 value for the areas you're changing. That concludes this video. Make sure to check the description for useful references.